Let's look at superclasses and subclasses. This is an example of a superclass called geometric object. Both circle and rectangles are the subclasses of this geometric object. Remember the UML? Symbol is this open, unfilled arrowhead. This means both circles and rectangles are the subclasses of geometric objects. There's a lot of inherent attributes in both circles and rectangles. These are not shown, but supposedly there are some methods and properties that are in both geometric objects as well as in circles and rectangle. Let's look at how these things are invoked. In Java, when a subclass constructor is invoked, such as when rectangle is invoked or when circle is invoked, it simply calls the constructor of its superclass, like geometric objects here. If the superclass constructor requires argument or user-defined constructors, these arguments must be passed explicitly from the subclass constructor using the super keyword. Let's look at this keyword closely. When we have a parent and child inherited structure in Java, we're interested in how the superclass is constructed versus how subclasses is constructed. Even though many of the attributes from parent gets passed down to its child class or subclass, the question is whether a superclass's constructor gets inherited by the child class. The answer is no. Superclass's constructor, as it turns out, must be explicitly invoked using the super keyword. The super keyword is used to refer to the subclass of the current object instance or to call constructors methods of the superclass. Super is primarily used in the context of inheritance. Specifically, super is used in the subclass's constructor. By calling super, we're able to explicitly invoke superclass's constructor. If this super is not used, then the superclass's no argument or default constructor is automatically invoked. Let's look at an example. Let's assume that we have a class named A, and this is its default constructor, as well as the user-defined constructor. In certain text, this is also known as the no-arg constructor. Let's suppose we have B as its parent class, and A is the subclass. In A's constructor, if we do not have anything in there, then by default, there's a call to super. This super, in the context of A's constructor, calls the constructors in B, and this will be B's default constructor. So this super calls B's constructor by default. In the case of a user-defined constructor with some arguments, if we do not explicitly call any constructor by default, a call to A's default constructor is invoked. The call to super is always at the first line in the constructor. Let's say if you have some statements here and you choose to put super at the end of this or somewhere in the middle, this will give you compilation errors. Let's look at more examples. It turns out the keyword super could be used to refer to the superclass constructor as well as its methods. Using the super keyword to invoke a superclass constructor, we're able to initialize the inherited members of the subclass. If you do not explicitly call super in a subclass constructor, Java automatically inserts a call to the superclass's no argument constructor. We'll look at some examples next. Incidentally, you can use super to access methods of the superclass within the subclass. This is the second use case. This is useful when a subclass overrides a method but still needs to access the superclass implementation. Let's look at both examples. We have a parent-child relationship here. The design calls for a superclass animal with its subclass called dog. The construction involves the use of this extends keyword, which allows dog to inherit from the animal object. We have a sound method in this subclass. Notice that in this sound method, there is a call to super. This is to invoke the animal class's sound. Super in the pure inheritance manner allows for use of the super keyword dot into its parent class's method called sound. This allows the subclass to call the sound method. we don't use this, as this refers to the doc itself, and we don't also call animal.sound. The sound here is not static, nor is the animal itself. So the only way for a subclass to ever get to a superclass method is by way of issuing the super dot, the name of the method called. This allows a subclass to overwrite a method but still needs to access the superclass implementation. If we were to run this super.sound is going to make a system out print line called animal makes sound. After that, the flow of control returns to the next line, which prints dog barks. Let's look at how super is used in the context of a constructor. To do that, we can create an animal constructor with the system out print line called animal constructor. We don't need this anymore. Similarly, we will create a dog constructor. We will invoke super in the dog constructor and system out print line dog constructor. If we were to run this in a console application, whenever a dog instance is created, the dog constructor is invoked. The very first line of subclass constructor calls for super, which takes the flow of control to printing out animal constructor first. The flow of execution completes and returns back to the second line of the constructors in dog, printing out dog constructor. Lastly, the keyword super cannot be used to access members of the superclass, as there is no subclass context. It is only valid within the context of a subclass. In summary, the super keyword is essential for managing inheritance relationships and accessing superclass functionality within the subclass in Java.